In this video, I will show how to make a PacMan game. The first thing we need is a new project. Now we have a blank project. The next thing we need is a new scene. Open the default scene and just save it to create a duplicate of it. For our PacMan world, we want to have a maze. I take this as inspiration. Use the gray boxing tool to create a maze. I make each wall 1 unit thick and 1 unit high. This is the total play area. Now create the inner maze structure. Now that we have our maze finished, we need a camera from which to render it. Usually if we press play, nothing happens. Similarly, if we press play the game, we just see the world from the editor camera and can move it around. In the final game, of course, we want to have a top-down view. So create a new camera object by pointing somewhere and pressing Ctrl-Shift-X to create a new game object, and then attach a camera component. Position the camera such above the play field that you can see everything. Now that we've positioned the camera properly, set its usage hint to main view. And then press play the game. As you can see, we now observe the playing field from top down. We can't move the camera around anymore. The next thing we need is our player PacMan object. For this we start with creating a simple sphere. In the mesh asset, select from the primitive type sphere. Leave everything else to default, set the segments and stacks to 16, then press transform. We don't have a material yet, which is why the object doesn't show up. Use the prototype white material. Transform again, and now our sphere is finished. Go back to our level and add the sphere to our scene. We can change the color to yellow so that it looks more like PacMan. Add another sphere, scale it down, set its color to black, and use it as an eye for PacMan. Parent the spheres to the big sphere so that they move along with it. This way we know in which direction our PacMan object is moving. To be able to move our PacMan object around, we need a character controller. Create a new object, remove the shape icon, and add a Jolt character controller. First attach the spheres to it. Then position them properly. Finally, adjust the size of the character controller capsules. For the PacMan game, we only need to change the shape radius and stand height. We also need to set collision layers on the character controller, so that it knows what to collide with. Currently there are no collision layers set up in the project yet. So go to Editor, Project Settings, Jolt Project Settings. And here we have a default setup of collision layers that we don't want. So just start with removing all collision layers. Now we use the default layer for all scene geometry. Next we need one layer for PacMan himself. Then we want to have a separate layer for the ghosts. We do not want the ghosts to collide with PacMan, so disable those collisions. We also don't want the ghosts to collide with themselves. Later we want to be able to detect whether PacMan hit either an item that he can pick up or another ghost. There are multiple ways to do this, but here we just use two separate collision layers so that we can easily distinguish which one it was. The pickup items, such as coins, don't need to interact with anything in the world, so we only need one collision layer for them. We can use a trigger later on, which uses this collision layer to detect when it overlapped with a pickup item. The ghosts need to be able to collide with the world, so they get their own collision layer. We also need to detect when PacMan collided with them, so we use a different trigger and therefore also a separate trigger ghost collision layer to be able to detect that. Close the Jolt project settings. Select a different object and then the character controller object again to be able to change the collision layer. Now we can assign the PacMan collision layer on our object. Now we have an object that looks roughly like PacMan and can be moved around the world using the character controller. The next thing we need is to be able to handle input. Add an input component to the PacMan object. The input component uses an input set that defines which keys trigger which input actions. We need to adjust the input actions that we want. Go to Editor, Project Settings, Input. Here we want to create 4 input actions so that we can move PacMan in all 4 directions. You can also assign alternative input slots so that, for example, you can play it with an Xbox controller as well. Close the input configuration. Next, we need to write some custom code. Create a C++ project. Here we have our default C++ project. It contains the game state and 2 sample components. We don't need any of those components, but we can rename them so that we can use them for our PacMan object. Rename one of the components into a PacMan component and remove everything that we don't need. When you're done renaming, compile the solution. Then switch back to the editor. Select the PacMan object and open the Components menu. As you can now see, there's a PacMan folder, and in it we even have our PacMan component. Make sure to attach the PacMan component to the top level object in our PacMan. It has to be located on the same object where the input component and the character controller are located. Now this component is supposed to handle our input and steer our character controller around. If you want to know what a component is able to do, you can use the documentation button next to the component name. This will go straight to the ezEngine documentation. Here you will see that the input component sends an easy message input action triggered message. So that's what we want to react to. If you need more information about this action or any of the components, you can either go directly to the API docs and search for the message here. Then you will get the official documentation about it. Or what is often more useful is to have a solution of ezEngine open and jump directly to the implementation. Here you have the same documentation as online, but additionally you can also look at the implementation and see some deep details that are hard to see in the documentation. For example, here you can see more easily which file you need to include to get to this component or to this message. So now that we go to our PacMan component and add a message handler for the input message. A message handler looks like this. The name is arbitrary, but I usually use the same name as the message and just put an on in front of it. Of course, now we also need to have the include for that message. So we go to the ezEngine project and just copy the path of this file here. Go back and add the include. Make sure to use the relative path below the ezEngine source tree. Now create the implementation of that message handler. We also need to register this message handler in the reflection data so that the engine knows that there is a message handler for this message type. A message handler is registered this way. This block describes the bunch of message handlers that we have. Now we tell it which function to call when a certain message type arrives. We can test this by using some log output. Compile the project and switch back to the ezEditor. It automatically reloads the updated DLL. Now let's give it a try. Press play the game. When we press the left, right, up and down arrow keys, the object will get an input message. We can have a look at the log in the editor to see what happens. Next, we want to hook up this input to the character controller. First, I need a variable to store into which direction our PacMan is currently walking. Then I want to adjust the target direction depending on the input that we have. Also, I want to ignore input when people just released it button. This component has an update function that is triggered once every frame. We use this to change the state of our PacMan object. We simply rotate the entire object into the direction that it is supposed to walk. The component is attached to a game object. The game object is the one that stores the location and rotation, so we need to adjust that one. Compile the code and give it a try. Press play the game and try out the keys. As you can see, our PacMan object is rotating in place into the direction into which I press. Now all that's left is that it actually moves forward. To tell it to move forward, we can send a certain message to the character controller. We use the message ezMoveCharacterController to tell the character controller component that it should move the object. Again, you can look up the necessary include file directly in the ezEngine source code. We fill out this message and send it directly to the input component. Here we just instruct the character controller to move forwards at a speed of 2 units per second. We don't need to send the message directly to the character controller component. Instead, we can just send it to our owner object and it will be delivered to all components that handle this type of message. Messages are pretty much like virtual functions, only that they don't need to be implemented on every object. Additionally, you can also send messages with a delay if you want to trigger something sometime in the future. Compile the project and try it out again. As you can see, our PacMan immediately starts running away. Maybe we should place it directly in the maze. Nice. Now we can use the input keys to steer it around the maze. Of course, there are a lot of improvements that we can make. For example, we can prevent it from switching direction when it is facing a wall. Such details are implemented in the sample project accompanying this video, but for now I will keep it like this. Next up, we want to be able to collect some coins. We start by creating a coin object. So let's build a coin. We use one object as the parent, and then we attach a mesh component for the shape. We reuse our sphere object. Give it a nice color, make it glow, and scale it properly. For easier placement, make sure that the parent object is located on the ground and the mesh object is positioned above the ground. Now we need to give the coin a physical shape so that we can collide with it. On the parent object, add a jolt actor component. Use the dynamic actor component and set it to kinematic, because we don't want it to be simulated. We also need to have a physical shape. So add another object and attach a jolt sphere shape. Position this so that we can properly overlap with it. Now on the dynamic actor component, choose the pickup collision layer. This way we can make sure that PacMan overlaps with these objects, but the ghosts actually walk through it. Finally, move this object into a prefab. Now that we have our coin, we can place multiple instances of it in our scene. Press play the game to test what happens. As you can see, PacMan is walking straight through the coins. This is as desired. Now our PacMan object needs a way to detect that it actually hit a coin so that we can pick it up. For this, add a trigger component to our PacMan. On the trigger, we select the pickup collision layer so that it only fires when it hits an object that also uses the pickup collision layer. We give it a trigger message so that we can later on distinguish which trigger fired. Additionally, the trigger needs a shape with which we define in which area we actually search for things. We can just attach the shape to this object. Again, use a jolt sphere component. Now we need a message handler for the messages that the trigger sends. Again, have a look at the documentation for the trigger component. Here we see that it sends an easy message trigger triggered message. So we add a message handler for that to our component. Don't forget to register the message handler. Now whenever we hit a coin, we should get this message. We can make sure that it came from this trigger by comparing this string. Now of course we want to do something with the coin. So the easiest thing we can do is to just delete the coin. The trigger message sends which object triggered the trigger. So this is the MH triggering object, game object handle. We can just tell the world to please delete this object at the end of the frame. Compile the code and see what happens. As you can see, whenever PacMan walks over a coin, the coin is removed. Now all we need to do is count how many coins we walked over to have a score. Next up, we need some ghosts. Go to our C++ project and reuse this second sample component that we have to turn it into a ghost component. For now, we have a component that doesn't do anything. Compile it, go back to our project and use the PacMan component as a template. We just copy the entire object and then we will remove the PacMan component and also the input component and the trigger. But we leave the rest because it also needs a character controller and some of those shapes. We can change the color so that we know that this isn't PacMan. And then on the top level object, we add our ghost component. Now, since it also has a character controller component on it, we can also just tell it to move forwards. The tricky part will be to make it steer. If you simulate now, it will move forward and run into a wall. Just as with PacMan, we also give the ghosts a target direction to walk into. And we also make them rotate into that direction. All we need to figure out is which direction they can actually rotate into. Now to figure out whether a ghost ran into an obstacle and which options it has to continue, we use Raycasts. A Raycast basically casts a ray from a certain position and detects whether it hits a wall somewhere. To get access to Raycasts, we need to get the physics world module interface. The code for the interface is defined in this header. We query the interface from the world. Now that we have the interface, we can call all sorts of functions on it. Again, have a look at the ezEngine source code if you need to know the details. So what do we do here? We cast 4 rays, all starting at the position of the object, though we add an offset to the Z position so that we don't cast the ray directly in the ground. And then we cast each ray into one of the 4 directions. The ray has a length of 0.55. That's because our object, that means our ghost, has a radius of 0.5. So we cast it a little bit outside of this range. In the params, we only say that we want to collide with static objects. We do not want to hit other dynamic objects like the other ghosts or the player. So all we are interested in is to see whether there's a wall directly in front or next to us. Then we want to store the results of these raycasts. So now for each direction we know whether there's a wall. Next we check whether the direction that we're currently walking into is occluded, and if so, switch into another direction. So now when the target direction is occluded, we just pick one random other direction. If that's occluded as well, we just pick another one, until we find one that's free. Compile the code and try it out. As you can see, our ghost now randomly walks through the maze. Of course, you can improve the logic of the ghost significantly. In the original game, each of the 4 ghosts has their own behavior. However, that is beyond the scope for this tutorial. What's now missing is that we detect when PacMan actually hits a ghost and loses the game. Again, there are multiple ways to do this, but the easiest way is to just add another trigger and detect whether we overlap with the ghost. So select the PacMan object and add another trigger. This time choose the Trigger Ghost collision layer, so that this trigger only fires when we overlap with a ghost object, and don't fire when we overlap with a coin object. In our code, we now need to handle this somehow. We already have a message handler for triggers, so we just check for the second trigger by comparing whether we now got a message from the ghost trigger. And the easiest way to prevent players from continuing playing is just to delete ourselves. Compile the code and see what happens. Now let's run into the ghost, if we can find it. As you can see, we can walk straight through it, but nothing happens. That's because we need to give the ghost another physics shape so that we can actually detect it. Select the ghost object and attach another object so that we can give it a physical shape. Add a dynamic actor and another sphere shape. Set the actor to kinematic. We can attach the sphere directly on the same object. Check the size of the sphere and its location. Make sure that the dynamic object uses the ghost's collision layer. And let's try again. Voila! As you can see, we hit the ghost and PacMan got deleted. So now we can't continue playing the game. Of course, there are a lot of things that we can add to this very bare bones game. For one, we should count the coins and show that on screen. Additionally, you want to have multiple ghosts, maybe even with different behavior for each of them. Also, the input behavior of PacMan is very rough, and we would want to improve on that. Finally, you can add a lot of sounds for when you pick up coins, when you lose, when you win, and so on. However, for this video we will keep it at that. If you want to know how to accomplish the other things, please have a look at the PacMan sample project in ezEngine.